Hello, welcome back. We're again looking at Godot, and you will see that I have already loaded up and created a project here. There's a good reason for that. This step of the tutorial does not have you really create a project or a scene. It just goes over some code that you can use. So I figured I would put it together into a project that actually does something. And I'm going to say right now, it's been said before that a good way to learn something is to teach it. I'm going to have to agree with that because I definitely feel more at home after having built this project out of scraps and nothing to show you. So if you need to learn a game engine, something technical, anything at all, I would recommend thinking how you would explain it to someone else and walking yourself through how you would teach someone. So this goes more into scripting. First is processing. There are actions in Godot that are triggered by callbacks or virtual functions, so you don't need to write code that runs all the time, but it still can be helpful to do that. There are two types of this sort of processing. There's idle processing and physics processing. The idle processing is done with the underscore process function of a node. And that is one of the ones that is filled in when you create a new script. It's underscore ready and underscore process are created, and process is commented out. And how often it runs depends on how many FPS your game gets. So how many frames per second it draws to the screen, that's how many times per second it will run. And to deal with that variability, you have the delta parameter provided by the engine, which is the change in time, the amount of time that has passed since the last frame. And what you can do, for example, what is very common, is to multiply your movement amount of your character or your enemy or anything that moves by delta, so that it is scaled with the frame rate, so that it is a consistent speed and it is not reliant on the frame rate. Physics process or underscore physics underscore process is the same, but it's for physics, and by default it runs exactly 60 times per second all the time. But you can change that by going to project settings and going to physics common physics FPS. Let's see, where is it? Physics common physics FPS. But the underscore process function is not synced up with physics, which is something to keep in mind. And on a single-threaded game, it's done after the physics process function. So here it gives you a bit of code. This is the most code that it gives you in this whole section, which is why I made this project. And let's go ahead and take a look at that now. Nope, this one. I just wrote this up. You initialize an accumulator. You just create a variable, set it to 0. And you use this underscore process function, and in that function you set the accumulator equal to what it was plus delta, and then you just change the text of this label right here that says ready go to the string version of what the accumulator currently is. String just is like text. And we will see that indeed it shows a counter increasing each frame. Yep, 1 second, 2 seconds, 3 seconds. And please pay no attention to the buttons behind the screen. They will come into play shortly. So groups. Groups are a way to group things together other than the node tree system. So you might have something, you might want this button and this panel and something down here that's unrelated to be related. Like it's something that's not under this panel at all and has nothing to do with it. It might still have something to do with it. Not symbolically, syntactically, whateverly. In some sort of way. And there are two ways to add things to a group. You can click on it, go over here to node, go over here to group, type in, click add group, which you can just almost not see the add button here. I would recommend that. But what I did is the second way, which adds it via code. So let's see. Label, yes. For this one, for this label and this label, which are here and here, ones that say listening, I have under the underscore ready function, I have add to group broadcast. And broadcast is just what I decided to call that group, because that's what the button says. So anything that operates on that group will affect those nodes. So you can see those. And this button here will check on the scripts. Doesn't have a script. That's right. It's under panel. So on button pressed, this is the control simply called button. There's no code there right now. We're going to change that. On button pressed, we want it to change. We want it to call function. So we're going to do get tree dot call group. Group is called broadcast. That is a string, and the second argument, the function that we want to call is called change face. I'm trying a thing where I have some of the code already typed out, and some of it I'm typing out for you, and I hope it works as an instructional method. But we have change face, but it does nothing right now. We want to make it change text. So this would be label.text, or the text of this label, label 2, equals message received. Now we're going to save that. And this one is also in that group, and it also has its own function called change face. Change the text on that to message understood. Now I'm changing them to different things so that it differentiates them but demonstrates that they are both under the same group and they both have their own function with the same name that does different things on each of them. If message received, message understood, and that one hangs off the panel a bit, but never mind. So that works. We have a signal being sent from a group, which I did use the node signals. I used this to create the code here. All that does is just do func on button pressed, and then puts, I think, pass under here. But what that, and you can type that yourself, it does the exact same thing. The only difference is when you do it by going through the inspector or this tab and the node and connecting it that way, you get a nice little indicator on the code of what is connected on that line. If you click on it, it says button, signal press, target panel. And I like that. So I'm going to do it that way from now on. That and using the node groups are two ways that I actually would rather do the GUI sort of engine editor way rather than the code way, because it makes things easier and make more sense in the editor, and you're going to be using the editor, so you might as well. You could skip out on the editor largely, but I don't think you could skip on it entirely, so there you go. Let's move this over a little bit so it doesn't hang off. Alright, next up is notifications. Notifications, we're not really going to... Wait a minute. Oh yeah, there's a thing to get nodes in group, which could be very useful. And the thing about adding things to a group this way, I should also say, is that you can't change it later. I mean, you can change it later, but you can't change it while the game is running. So if you wanted to say you've betrayed your character, the player has betrayed their allies too many times, and now the allies are going to turn against them. So you change your allies to the enemy team. An easy way to do that would be to set them in the enemy group. And to do that, you need to do it in code. You could probably do visual code, but setting it initially here, it'll just stay that way until you change it. So, notifications are sort of an under the hood thing. You can look at the class reference. They use underscore notification, but it's better to use overridable functions. Overridable functions are things like enter tree, ready, which we've seen, exit tree, process, physics process. Enter tree is like ready, but it is not quite the same. So when it enters the scene tree, it becomes active. Child nodes have not entered the active scene yet. In general, it's better to use ready. And this is exit tree runs when it exits the tree. Children nodes have all exited scene tree at this point and all became inactive. And then the other three we've already gone over. Now, creating a node. For that, you would set a variable and then possibly under ready, possibly somewhere else, you would set that variable equal to some node type dot new, left and right parentheses. And then you would do add child of that variable. So that's like the second largest code block that it gives you in this part. So I believe under here, yeah, right here is where I'm going to be doing that. So I have variable lab. I'm going to use that. Lab equals label dot new. Add child lab. So now when we run that, button 2 will do something new. Now there is a bit of thing here, free. I looked over that. I could not seem to get it working quite right. I am probably being dumb, or the way that I used it is not quite right. But we will come to that. Now spawn. Okay, I messed something up. Oh, yes. Yes, I typed this out before, so I can just undo and see what I did. I didn't set any text on it. Add.text equals I'm here too. That's a bit of a nice feature. If you have the if you've already run the game and it's currently running, you can click there to rerun it, to close it, and immediately start it back over. Oh, there it is. Please don't crash. Spawn. I'm here too. Alright. So to delete a node, you can use free or queue free. It's better to use queue free because if you use free and it's not ready, something is blocked, then the game can crash. That's bad. So you can instance things from code, which is good because if you want an enemy or a weapon to create bullets, projectiles on demand, the way you would probably want to do that is instancing. So you better be able to instance from code. So to do that, you would want to do set a variable equal to load, and then you would use this res path name. So somewhere within the folder that has your code and other resources, you would do some scene.tscn. You could also do preload, which is only available to GDScript, but it can be more convenient because it happens at parse time, which means when the code is interpreted, when it's turned into something runnable. When this code is turned into something the computer can actually run. So by doing that, you'll see I have that here already. New scene equals load or fun.tscn. Let's load that scene up. That's just a panel and a label. So I have the scene loaded, but that doesn't instance it. You need to set a node equal to an instance of that, and then add that node as a child. Which I thought I had deleted, but yes, I have it. Our temp panel equals new instance.instance. New scene.instance, and you add child temp panel. Much like I did add child lab. That adds it into the node tree. Because everything has to be somewhere in the node tree. So the advantage of the two-step process is you can have a scene that's ready and then instance it when you need it. So this is already loaded up here, and then you can instance it multiple times. Like I could make this button also do it. Let's see the fruits of that labor. Last thing is to register scripts as classes. It doesn't really say what the benefit of that is, other than, or the use of that is, other than making it available as a thing in the editor, which is nice. You know, it's something that you can create a copy of it, and not as an instance, but as, like, say you want this panel here to be available in broader other sorts of ways. You could do it that way, it seems like. Yes, here, below there. And I had a button that said go away, and clicking it was supposed to make it despawn, but that didn't work. But I think that's about all of the important elements of this, and laid out, I dare say, a bit more helpfully than the actual text tutorial. So I hope that's helpful, and I will be back next time with like signals. Yes, next time is signals. See you then.